Okay, so let's continue with our stuff. Now, last week, what we had done was we had finished with that basic PT machine. That was what we did in the last session. And I told you that from now onwards, whatever we do, that is going to be completely online. Okay, we're not going to have to download anything. Okay, so now what we are going to do is we are going to work on some kind of CTF challenges. Now, it's a different format as compared to what we've seen so far, and we'll return to what we've been doing. We'll return to the original format as well, but just for a couple of sessions we are going to look at this different format because it is a nice CTF challenge, and basically it gives you a lot of uh, you know a lot of good basic familiarity with Linux commands that you'll need to use whenever you are working in infosec. Okay, so I'm just going to wait for my VM to boot up, and then I'll show you what we're going to do. Okay, so just give me a minute while it boots up. All right, so this is booted up, and now again here I'll be using my Linux, attacking Linux as well. So the challenges we need to do, we are going to do them on Linux, and the website that I'm going to use is overthewire.org. So I'm just going to copy this link and I'll also mention it in the chat. So now they have a different kind of CTFs, and these CTFs are known as war games. All right, so now they have lots of different war games. I'm going to do Bandit here. The reason I include Bandit here is that I believe that a lot of the commands that it shows you are going to be very useful, regardless of whether you are solving CTFs or whether you're just working with Linux in general. So that is why I would definitely recommend that we do this, and we are going to work on this. Okay, so now the way to do this is it has different levels, and all the levels are described here on the left hand side column. You start with level 0, and the goal for this level is to log into the game using SSH. Okay, so we'll be using our Linux systems and logging in to this game server using SSH. So now, however, you for SSH to work, you need some credentials. So now the host name where we need to connect is this bandit.labs.overthewire.org. This is the port number, and they've given a username and a password. Okay, so that is all the information that's required to make an SSH connection. So let's do this. So the command to connect is SSH and bandit 0 at the rate. Now the host name comes here, bandit.labs dot over the, oh, missed that dot here, .org. Now if this were running on the default port, what is the default port for SSH? Can you tell me the default SSH port? Forgotten already. Port 22, that is correct. So by default, SSH servers run on port 22. What? Oh, okay. But in this case, we know that port 22 is not where the server is present. S1 port 2220. So when I'm writing this command to connect, I'll need to specify that port. So I'll go to this command line and -p on the port number, which is 2220, and this is it. I press enter. Now when you connect to a host for the first time, you'll get an error. Sorry, no, you'll not get an error. You'll get a message saying that do you want to trust this certificate? Do you want to trust the server? So since you want to connect there, your answer is going to be yes. Okay, so since I have already connected previously as well, so I don't get that message. Now I'm entering the password, which is bandit 0, and I press enter, and I am now logged in using SSH. So since I'm now logged in, I can now work towards solving this level and moving on to the next one. So I'll just come to this.
So actually, that in command that bandwidth at the right. That's what it means.
Pardon?
The command can show that.
Again,
Com,
your voice is a
com,
little.
hello.
Hello. Yeah.
That's in the command bandwidth at the right. What does it mean?
Your voice is breaking up actually. Could you write in chat what you're asking?
Hello.
Yeah.
That bandwidth at the right in the command. Used in the command. No.
Bandit.
Bandit 0
That is the username.
username.
See, when we saw this part, uh, it says that the username is bandit0 and the password is bandit0. And this part, this is the host name. See, you can either provide a host name or you can provide an IP. Now you need to tell SSH where you want to connect. So the way you write it is SSH and the username @ hostname. So username is
Okay.
bandit0 and hostname is bandit.labs.overthewire.org. All
Okay.
of
Okay.
these details are mentioned here. That's where I'm taking these details from. Okay,
Okay.
so now that we are logged in, the first level is quite easy. It's fairly straightforward. It says that the password for the next level is stored in a file called readme located in the home directory. Use this password to log into Bandit1 using SSH. Also, whenever you find a password for a level, use SSH to log into that level and continue the game. All right, so where are we currently? We are in the home directory for this user. Okay, so all right, and now I'll just do ls, and there is a file called readme. So I'm going to do that. I'm going to read the file, and this is the password for the next level. So it's fairly straightforward. Okay, just copy it. I'll exit, come back to my system, go to this command again, and instead of bandit0, I'll just write bandit1. The rest is going to remain the same. So I do this, and it should prompt me for the password. And when it does that, I'll enter the password that I've copied. And now we have logged in as bandit1. Okay, so the first level fairly straightforward. Let's move on to the next one. So the next level says that the password for the next level is stored in a file called dash located in the home directory. So it says that the name of the file is simply dash. Okay, so let us come back here. ls-al just to make sure. Okay, so there is this just one file called dash. The rest is all stuff that's no, we don't use, but the system uses. Okay, so if I try to just normally output it, this is not going to work. Okay, it's stuck. Okay, it's not going to give us any output. It's just going to stay stuck there. Now, how would I go about solving this problem? Do you have any suggestions on how we could do this? Sudo, but okay, let's try. I'll just cancel this command. Okay, so you want us to try to use sudo. So we don't really have sudo permissions here. Let me check the ID for this user. So we are not in the sudo group. So that means we cannot use sudo, right? And the issue is not for permissions. As you can see, as Bandit 1, I am in the Bandit 1 group, so I have permission to read the file. So the permissions are not really the problem here. The name of the file is a main problem. Okay, the name is simply a dash. Even if you insert it within quotes, let's see what that gives us. Will that solve the problem? Even that does not solve the problem. I just control C to cancel this command. Now, okay, rather than how to solve this problem, do you understand why we are getting this problem? It's name simply. Yeah, but that shouldn't be a problem, right? Whether it's a short name or it's a long name, system shouldn't really give us an error just because of that. But here, what we've done is actually what they've done is they've simply named the file as this dash. Now, a dash or a hyphen is something that conveys a special meaning to the system. Let's say, for example, even when I use any command like SSH or even ls, I use hyphen, like in this case, to specify some options related to that command. Now, even the cat command has options that can be specified using hyphen. So, when you enter a hyphen, the system expects you to give some command there. But we are simply trying to access this file. Currently, the problem that we are getting is that the system does not recognize that I'm talking about a file and that I'm not trying to specify any option or any switch with a command. The system does not recognize that right now. So what I need to do is I need to do something which will convey to the system that hyphen in this case is simply the name of the file that I'm trying to access. It's not a special character because hyphen conveys a special meaning. So currently it's not that. It's simply something that I'm using to as a sorry, it's something just that's a file name and I just want to read that file. That's all. I need to make the system understand that. Now, what is one property or one attribute that every file has? Of course, other than the name, what is one property that every file has? It's path. Every file has a path. So what I can do is I can specify the file path. We are currently in home bandit one. I can say cat home. Okay, sorry, I misspelled that. Home bandit one. And within bandit one, we have this file hyphen. So if I write this and press enter, now the system understands that we're talking about a file. So it gives you the password, it gives you the content of the file. There is another way of writing it, a slightly shorter way of writing this exact same thing. Instead of writing cat and the complete path, you can simply say dot slash and the hyphen. So that's also going to give you the same result, because dot is used to a single dot is used to represent a current directory, the current directory, and a double dot is used to represent the parent directory. So the single dot we can represent the current directory, and that is also something you can use. So now you just copy this, exit again, come over to the next one, enter the password, logged in successfully. Now let's see. It says the password for the next level is stored in a file called spaces in this file name located in the home directory. Okay, let us take a look. ls, okay, spaces in this file name. Now this is just a single file. However, if I just directly try to do this, it's not going to work, because here again the system thinks that I'm talking about four different files. Okay, it's looking for a file called spaces, another file called in, another file called this, another file called file name. So but that's not the case. It's simply a name that it's a file name that contains spaces. So again, just like in the previous case, the file name is the actual issue. So any suggestions here? Path. Okay, let's try that. So let's say cat home bandit 2 spaces in this file name. No, it still just considers this as, okay, actually I misspelled it, but even if I were to write this, it considers this as one file name with a path and the other three as separate files. So even if I'm providing the complete path, I'm getting the same issue. Now again, the problem here is that space is a special character. It's used to separate either a command or two commands and parameters. So even here what we do is cat followed by a space followed by the file name. So space is used to separate two things, so it's a separator. Can we use underscore instead of space? But that is not the actual the original file name. So if I were to use something like cat spaces underscore in underscore this file name, it would not be able to find that file because it doesn't exist. There is no file called spaced underscore. Okay, because see, the original name of the file does not contain underscore, that's why we can't use it either. So however, there is one way to do this. Actually there are a couple of ways to do this. Let me show you the first one, which is simply adding single quotes or double quotes, that's up to you. If you do this, it's going to understand that it's a file name and it's going to output the file. Because what we've done here is we've enclosed the whole name within quotes. So anything that's within quotes is considered to be a single parameter, right? So the entire file name it treats as one value and it sees that there is a file by that name and it outputs that. So this is one solution that works. There is also another way to do this without quotes, of course. Now, even with quotes, you have two options. You can either use single quotes or you can use double quotes. That's up to you. Okay, so single quotes and double quotes both are going to be fine. Also, what I can do here is, okay, see what happens when I just start writing the name and I tab it out. So the system, but in previous case does not work because see both are very different kind of characters. Space is a separator and hyphen is a prefix. Okay, so both are treated separately by the system. So quotes do not work for that, but quotes work in this case. And also notice what happens now. If you just cat and you just start writing the name of the file and tab it out, the system, when it auto completes your file name, it adds these backward slashes automatically. You see this? So it automatically adds these before every space. Now if you press enter, this is also going to work. Now why this is being used is because when you enter this backward slash, it tells the system to treat the next character as a normal character instead of a special character. So space, a special character or a delimiter or a separator. If you have this backward slash before it, the system interprets that as okay, what I have here is simply a normal character and should be treated as such. Okay, so space is not going to be treated like a normal space just as any other character. And that's why this method also works. So we have this password, copy it, exit, come back to this command, replace 2 with 3 and case just enter your password and logged into the next level. Right, let's take a look. The password for the next level is stored in a hidden file in the in here directory. Okay, this is again pretty straightforward. There's the in here directory. You go into that directory, ls-a is for viewing hidden files, and you see this file dot hidden. Just simply cat it out, and this is the password. So again, this was also pretty straightforward. Nothing too complicated here. Just copy it, exit, change the command again, and paste your password, and we're good to go. Okay. Now in this level, the password is stored in the only human readable file in the in here directory. All right. So let's see what we have. We have this in here directory. I'll cd to it, and it says that it's in the only human readable file. Now there are files 0 to 9, so there are 10 files. Let's try outputting any one. Let's say file 3. Okay, and again these files start with hyphens, so you'll need to specify dot slash before that. File 0 3, let's say. Try accessing this. Okay, now this has some kind of data within it. Oh, it's a binary file, but it's definitely not a text file. So our goal here is to find the only human readable file or the only text file here in this directory. Okay, now for every level they have given you some hints in the form of commands that you may need to solve this level. Okay, so you can always refer to these. Also, now see, if here are 10, we have 10 files here, so you might think that okay, it's just 10 files. I'll just output each and every one of these files, and I'll eventually get the answer. While that may work, I mean that will work of course, but it's not an efficient solution or the correct solution here. Okay, let's say you have more than 10 files, let's say you have 100 files or even 1,000 files. You're not going to be outputting each of those files individually, because that is going to take up a lot of your time. So here we need to look for a solution that will work for us. We need to look for a command that will tell us this the status or the situation for these files. Okay, we need to look for the text file, and we know that the files here, you have just one text file, and the rest are all just data like the one we've seen. So can you tell me what command we can use here? Okay, so there is a command called file. And when you use this, it and you provide an input, you provide the name of a file, it tells you what kind of file you are looking at. Okay, so whether it's a text file or whether it's an executable, whether it's an archive, whatever kind of file is present, it tells you that. Okay, so now what I want to do is I want to run the file command for all the files here. Normally what you can do is you can simply use file and then you can use this wildcard asterisk, which is going to run for all files. But since this is a special case, all our files are beginning with hyphen. If I use this, it's not going to work. So I'll have to use file dot slash and this hyphen, and I can add an asterisk to that. So it's going to run for all files, and it tells you that out of these 10 files, files 0 to 6 and files 8 and 9, they are data files, but file 7 is ASCII text. So that means that is the human readable file. It's the file that we're supposed to be looking for. So we'll just cat dot slash file 0. Oh, sorry, not 06, 07. So this is our password. Any questions here so far? No. Okay. So far we have done how many? We have worked on okay, 4 levels. All right. Now, if you want, while we're doing this, you can also just follow along. Okay. So that is also something you can do, because there's nothing to download here. All you need to do is just connect to this website using SSH. So you can do that from your command line simply. Okay. Now let's move on to the next one. Okay, logged in now. Now the password for the next level is stored in a file somewhere under the in here directory, and also it has the following properties. It is human readable, it is 1033 bytes in size, and it is not executable. Okay, so now they have given us three criteria to look for a file, and the password is in a file that matches all these given parameters or given criterias. Okay, so let's take a look at the in here directory, see what the situation is. Now within this in here directory, there is maybe here 0 to 19. So there are 20 directories here. And let's say we just randomly take any one of these. Let's say 10 ls. So every directory has around 6 files. Okay. Even if every directory has like 5 files, there's at least 100 files overall in these directories. So even if you could look at each and every individual file in the previous level, there's no way we're going to do that here. That is most definitely not an option. Okay, so we have all these different files and we have all these different directories, and they've given us some particular criteria to use. So based on this, we can narrow down, uh, sorry, not narrow down, actually based on this, we need to find the file. So in order to find the file, I'm going to use the find command. So if you're not familiar with the find command, you can look at the manual, and it's used to search for files in a directory hierarchy. And whatever criteria you want, you can specify. It has a lot of different options. Okay, so lots and lots of different options are present in the file command. You can filter by users, by groups. I think there's also something for executable here. You can also filter for executable files. There's also you're filtering by permissions. There's also something known as readable here. But in this case, readable does not mean human readable or text files. This simply means readable with regards to file permissions. So this is not useful to us. Now there's a size option. Okay, and it's mentioned that the file needs to be 1033 bytes. So the size that I'm going to specify, after the size, I need to add a suffix as well. And for bytes, we use C. So 1033C. All right. So now for the find command, I'll just go back to the parent directory here. So not CD. Now find. The first parameter your find command is going to take is the location. So where to search. So location we are going to use as the current directory in the in here directory. So just simply dot a single dot is going to be there. The first parameter for find command is always the location. So location is this directory, the in here directory. So we specify that with a dot. Now we can start specifying all the different criteria we want to search by. So the first thing I'm going to do here is I'm going to use size. So size is known to us as 1033 bytes, and we've seen that for bytes it's 1033 C. For bytes we need to add the C suffix. Okay, so that is the first criteria specified. Now for human readable, okay, now for human readable, there is no there is no option to specify that in the find command. So that is something that cannot be specified using the command. But the other thing, the executable thing, that can be specified, and we've seen that. Okay, there's the executable option, hyphen executable. But we need it to not be executable, so I'll just add a not here, and I'll press enter. Okay, I need to separate that with a space. Find. Okay, so based on the given criteria, it has found our file. So this is the file. I'm going to copy this and just say cat this file, and this is the password. Just copy this, paste the password, and we are logged in. Okay, so let's see what we are supposed to do here. The password for the next level is stored somewhere on the server. Okay, so they haven't specified the exact location, the exact directory, somewhere on the server, and has all of the following properties: owned by user bandit 7, owned by group bandit 6, and 33 bytes in size. Okay, again we can use the find command. Can we, or can we not use the find command here? Yes, we can use that. Okay, so we can use the find command here, and just in this case what we have is that the criteria that was specified to us, that is slightly different, and the location, instead of looking within a particular directory, we have to look within the entire system now. So other than that, this is definitely usable. Find command is definitely usable here. So let's go back here, ls. So there's nothing but the system files in bandit 6 home directory. So again I'm going to use the find command, and I'm going to specify this, which is the main directory which contains the entire Linux file system, because it says that it's somewhere on the server, so it could be anywhere in the entire system. So that means this is what I need to give here. Now for the next thing, it's We have our username and group name. So they've told us that it's owned by user Bandit 7 and group Bandit 6. So I can simply say user Bandit 7, user. So and what was the other one? 33 bytes in size. So size 33C. Okay, now we are getting some output, but this is a rather messy output here. Now the issue that's happening is, I know you're seeing all these permission denied errors. Why that's happening is because what I'm trying to do is I'm looking on the entire system. I'm looking at the entire system. But of course, as this Bandit 6 user, there are a lot of directories on the system that I'm not allowed to access. Okay, there's a lot of directories. There's a huge portion of the system that I cannot access. So that's why I'm getting all of these different permission denied errors. Now it's not something unexpected. This is to be expected. Okay, you cannot expect to have access to every directory on the system unless you are root. Okay, so this is to be expected, but I do not want to see these errors, because this over 90% of this output is just errors, permission denied. So what I can do is, at the end of this command, I can append this to redirect it to dev null. So input, output, and error are three things that are, when you denote them numerically, 0 refers to input, 1 refers to output, and 2 refers to errors. So 2 redirected to dev null is, this means that all the errors that I get, I'm redirecting them to this dev null. What is dev null? It's inside the dev directory. Dev means devices. It contains all the devices that are connected to your system. And there is a file called null. So it's the null device or the null file, you can say. And any input that is sent to this file, it gets discarded. So that's what I'm doing. I don't need to see these errors on the screen. I don't need to store this information anywhere. I simply want to discard the errors. So that's why I use this. Now I press enter, and you can see that now I just have one thing on the screen, which is the desired output. But earlier I was just getting a lot of random useless stuff there. So I'll just cat this out, and I have the password for the next one. Let's see what we have got now. The password for the next level is stored in the file data.txt next to the word millionth. Okay, let us check this. We have a file called data.txt. All right. And now I'm just going to just look at the contents of this file very quickly, see what kind of content we have here. Okay, so there are some words written on the left hand side. On the right hand side, you have some text which looks like the kind of passwords we have been seeing for these levels. And it says that the password is next to the word millionth. So of course this is a large file. Okay, there's a lot of data. There is no way I'm going to just go through the entire thing and manually sit through this. Again, no way I'm going to do that. So I just come out of that, and there is a command called grep. Okay, so grep, what it allows you to do is it allows you to search for a particular keyword within a file, and if that file occurs, or sorry, if that keyword occurs anywhere within the file, it's going to give you as an output the entire line which contains that word. And of course, in case there are multiple occurrences of that word, it's going to give you all those lines where the words occur, where the word occurs. So the way to use it is grep, and the word that you want to grep. So here we have millionth, and the file, so that is data.txt, and as an output we've received the line containing the word millionth, and this is the password, since this tells us that it's stored next to the word millionth. Okay, so we have the password now. If there are any questions so far, feel free to ask. Okay, so next one. Password for the next level is stored in the file data.txt and is the only line of text that occurs only once. Let's examine this file. Okay, now again, huge file, lots of data, and it tells us that it is the only line of text that occurs only once. That means that most of these lines in that are present in this text file are occurring multiple times, but the line that we need is the one that occurs only once throughout the entire text. So there is a command called unique, and I'm just going to take a look at the manual. So if you haven't used this before, you'll find out how to use it. Unique, so it's used to report or omit repeated lines, and there is an option here -u. It's only going to print the unique lines, so that is what we need. We only need the unique line, at and so what it does is it filters adjacent matching lines from the input. So unique uh, -u data.txt, but it's giving us multiple lines when we were expecting just one. So can you tell me why this has happened? No. Okay, because just like we read in the manual, see, it filters only adjacent matching lines. So the first and the second lines are same, then is going to remove one of the occurrences. But if the first and third lines are same, or if the first and fourth lines are same, okay, just as an example, it's not going to filter that out. So what we need to do is we need to sort this data first. So I'm going to use the sort command. Let's say I sort it. See, what you see on the screen is sorted data. So now this Z90C, this line, now it is repeated multiple times, and after sorting, all these multiple occurrences are clubbed together. Same for this last one, and similarly it goes on for every other repeated line. Now I can use the unique command on this sorted data. So sort data.txt, I'm going to pipe it to the unique command. So unique -u, and you have your desired password. Okay, is this clear? If you have any questions, just feel free to ask them. Okay, don't hesitate. No questions. Okay. So now it tells you that the password for the next level is stored in the file data.txt in one of the few human readable strings preceded by several equal to characters. So this means that we need to again look at the file. So now it's giving me a warning that it's a binary file. See it anyway. Okay, let's say yes. Now this is not human readable text. This is binary data. But it tells us that the password is in one of the few human readable strings. So now there is a command called strings which filters out all the human readable strings and presents them to you. So strings, and I can use the strings command on data.txt. So let's see. Now it's giving us all the human readable strings. Now human readable does not mean that these are proper words or sentences or that they are going to make sense. It just means text that can be read. A text that is readable, characters that are readable. And also says that the password is in one of the few human readable strings and the password is preceded by several equal to characters. So before the password there are several equal to characters. So I can combine two commands here, strings data.txt, and I can say grep. Now it says several equal to characters. Several means at least more than one, so at least two. So I'll just say two of them, and I get 4 lines here. The password is, and this is the password. So I'm going to paste this here. 10. Now it tells us that the password is stored in, again, name is data.txt and it contains base 64 encoded data. So now base 64 is just, a kind of encoding for data. So this is the base 64 encoded data. And in order to decode this, I can use the base 64 command. If you want to look at the help section for it, so you can use the decode option or -d. So base 64, and I can provide it this file. So now you can see that the data has been decoded. The password is, and this is the password. Okay, so this is the password for Bandit 11. And okay, we'll continue with number 11 from tomorrow. Do you have any questions from whatever we did today? Now everything was clear. Good. Okay. Okay. Welcome. So